Welcome to BSc Statistics students. In this lesson, I explain problem 2 in critical path method CPM. So this is the problem. A project has the following schedule. Activities are given, time in days given. What is the time to complete the this particular activity? One particular activities are given here. What we are do is we have to construct first one network diagram, second one critical path, third one minimum time to complete the project. These are the three questions you have to answer. The first one, network diagram. The first question, I'm constructing network diagram. Already I have explained that in the network diagram you have to consider one after another activity. The activity is going to be constructed with the help of the two events, tail event, head event. So for example, you see here 1 2, 1 tail event, 2 head event, like that, 1 3, 1 4. So from first node, that is our event, first event 1, 3 activities are connected, 1 to 2, 1 to 3, 1 to 4. So that is what I am first of all constructing. So I am considering this is what the first node or first event, and from this this is one particular activity is connected by connecting the this particular event 1 to 2. By connecting 1 to 2, we get one activity. The duration of the time is 2. I am specifying here. And similarly 1 to 3, second activity, same 1 to another particular activity, it is forming the second activity, another activity 1 to 3, the time duration is 2. And 1 to 4, and then we have 1 to 4. I am constructing in this way, the 1 to 4, this is another activity with the time duration 1. I am writing time duration above the arrow, right? And thereafter 2 to 6, another activity 2 to 6. After that we have 5, we will see later, and 2 to 6, I am writing, that is I am connecting two nodes 2 and 6. I am constructing the activity 2 to 6. The time duration is 4. And 3 to 5. So 3 to 5. And any more? And 3 to 7, 3 to 5, 3 to 7. There are two activities. And 4 to 5 also. Hence, logically you have to think about this. From 3, you have to connect through two particular activities for two events, 5 and 7. 3 to 5, 3 to 7. And 4 also having is connecting with fifth node, another particular node, and activity 4 to 5. So therefore I am drawing 5 here. I am drawing the event 5 here. I am connecting 4 to 5 and 3 to 5. You see, logically you have to think and you have to construct like this. And 3 to 7, after 5 6, I draw 6 properly. I draw 6 properly because to looking these activities which should be considered after 5, you have to consider 6. You have to, it appears 6. 6 to be appeared after 5, like that, with maximum possibility. After 6, the 7 is going to be appeared. So I am drawing here the 7. So you see here 5 after 6, after 5 6, 6 after 7. I am forming like this. Okay, so 3 to 5 finished, 3 to 7, 4 to 5 also finished. And then 5 to 9, 5 to 9. Before that you have an activity 8. Okay, so therefore we see later 5 to 9, 6 to 8, 7 to 8. 8 activity here, 6 to 8 and 7 to 8. From 6 and 7, 8 activity is going to be considered. Eighth event is going to be considered, and it is going to be formed two activities. 6 to 8 and 7 to 8. If I draw 8 here, you have to connect from 7 to and 6 to. Like this I am constructing. And you have two activities left that is connecting with the last node. 9 is the last node, 9 is the last activity. It is going to be considered. Here from it is connected from 5 and 8. So 5 to 9, 8 to 9. So I am constructing like 8 to 9. So I am constructing like here 9 here, and so that I also connect from 5 to 9 and 8 to 9. So this is what diagram, network diagram. It is connected for all the activities. That is, it is constructed from all the activities. I see once again 1 to 2, 1 to 3, 1 to 4, and 2 to 6. Here is 2 to 6, and 3 to 5. This is 3 to 5, and 3 to 7. This is 3 to 7. 4 to 5. This is 4 to 5. 5 to 9. This is 5 to 9. 6 to 8, 7 to 8. 6 to 8, 7 to 8, and 8 to 9. 8 to 9 is this. So this is what a network diagram. Now you have to calculate earliest times and latest times. Now I explain through the forward pass calculations and backward pass calculations from the figure as well as through the formula. I explain the things. These two times. First of all, I indicate for all the events, I indicate E and L. E1, L1. Here I consider E2 and L2. E2, L2. E2 and L2. And here I consider E3, L3. Here E4, L4. E5, L5. E6, L6. E7, L7, E8, L8, and E9, L9 I consider at the end. Okay, I consider here E9, L9. Okay, and I start the calculations, the forward pass calculations. In the forward pass calculations, you see here, I put a heading here, forward pass calculations. Forward pass calculations, from which that I consider the value of E1, the first value is to be considered as 0. So E1 is equal to 0. I write here E1 is 0. And remaining all the formula, I give you the formula here. Ej is equal to maximum of with respect to I, Ei plus Dij. This is the formula I am specifying. If you have one node, one connector, then the formula is directly Ei plus Dij. More than one, then the formula maximum. So that is the reason why I combine the formula, and I have given one formula only, right? The first one is E1 is 0. The next connector, that is E2. E2 is, you see here, only one particular connection we have, 1 to 2. So therefore it is the formula E1 plus D12. E1 plus D12. What is E1? E1 is 0. 0 plus D12. What is D12 here? 1 to 2, 2. 0 plus 2, it is equivalent to be 2. So write E1, E2 is equal to 2. Clear? Now E3. E3 is also only one connection, 1 to 3. So therefore E3 formula, E3 is going to be calculated with E1 plus D13, because it is connecting with 1, 3. You have to remember I is equal to 1, J is equal to 3. So therefore E3 is equal to E1 plus D13. E1 is 0, D13 is 2. Therefore it is 2. So E3 is equal to 2. I am writing in the figure, that is network diagram. And then E4 is also, we have only one connector, 1 to 4. That is E4, the formula is equal to E1 plus D14 is equal to, the formula here, E1 is 0, D14 is 1, duration is 1, therefore 0 plus 1, 1. That I am writing here E4 is 1. Okay, and then E5, I am going one by one. E5 for which you have E5 for to calculate E5, we have two connectors, that is from 3 to 5 and 4 to 5. You observe the figure clearly, 3 to 5 and 4 to 5. So therefore I'm calculating maximum formula. I'm using the maximum formula, maximum of E3 plus D35 and from 4 E4 plus D45. So therefore maximum of E3 is 2. You observe here E3 is 2. So therefore it is 2 plus D35. I write the values here, remaining all the durations. D35 is 8. 4 5 is 3. 4 5 is 3. And 3 7 is 5. 3 7 is 5. And 6 7 5 9 is 5. And 6 8 is 1. 6 8 is 1. 6 to 8 1. 7 to 8 4. 8 to 9 3. 8 to 9 3. So now I'm coming back to calculation of the maximum of E3 plus D35. So E3 is 2, D35, you see here 3 5. 3 5 is 8. 8. So therefore 2 plus 8. And E4 plus D45. E4 is 1 and D45 is 3. 1 plus 3. So 1 plus 3. 2 plus 8 is 10. 1 plus 3 4. 10 and 4. Maximum is 10. Right? The maximum value is 10. So E5 is 10. Where is E5? Here. Here we have E5, it is 10. And thereafter 6. 6 is connecting from 2. You see, observe the diagram, network diagram. It is 6. 6 is connecting from 2. So therefore E6 is equal to E2 plus D26. That is 2 plus 4. It is 6. I write the formula here. I calculate through the formula. E6 is equal to E2 plus D26 is equivalent to be 2 plus 4 is equal to 6. Clear? Next 7. E7 is also connecting from one node, one particular event. 7, that is 3 to 7. Connectivity is 3 to 7. Activity is connected from third event. So E3 is 2 plus 5, it is 7. 2 plus 5, it is 7. So I'm writing E7 here, the formula. E7 formula from 3 7. Hence it is E3 plus D37 is equal to, E3 is 2 plus D37 is 5 is equal to 7. So I have already calculated. Now E8 is going to be calculated. It is connecting from two activities. That is two events. This activity is going to be formed. This event is going to be formed. Right? And 6 to 8 and 7 to 8. The two particular connections we have to the event 8. The two activities are formed. 6 8 7 8. So we have to consider the maximum. You see here E6 is 6 plus D67 is 6 8 is 1. 6 plus 1 7. And E7 is 7. 7 plus D78 is 4. 7 plus 4 11. The maximum 11. Right. So therefore I am using the formula here. E8 is equal to maximum of, it is connecting from 6 and 8 first. So therefore it is E6 plus D68 1. And it is connecting from 7. So therefore it is E7 plus D7 8. This is the formula, is equal to maximum I, the formula. Okay, maximum of E6. E6 is equal to 6 plus D6 8. It is 1, and E7 is 7, and plus D7 8 is 4. So it is 7. This is 7 plus 4 11. So hence it is 11 the maximum. So E8 is equal to, I am writing here, from 6 to 8, 7 to 8, the maximum is 11. E8 is 11. And then E9, last one, the one more. It is connecting again with the help of two events. This event is going to be connected and two activities are formed. 5 to 9, 8 to 9. You see, observe here 8 to 9 and this is 5 to 9. Therefore, I write the formula first. It is maximum of 5 to 9, that is E5 plus D5 9, and 8 to 9, that is E8 plus D8 9. So you have to calculate the value here from the maximum, that is E5. E5 is E5, that is 10 plus D5 9. 5 9 is 5, and E8 it is 11. 11 plus D8 9 is 3. It is 14 is 15. Therefore it is 15. You see here, I show from the figure, from the network diagram. 11 plus 3, 14. 10 plus 5, 15. The maximum 15. This is what the forward fast calculation. We have calculated from first node to ninth node. That is first event to ninth event. This is called forward pass calculations. We calculate the times of E, earliest times, which are called earliest times. Now backward pass calculations. Backward pass calculations. I write here backward pass calculations. So these are going to be calculated with the help of the E is equal to L for last node. Last node or last event. For last event. And we have to consider, it is not E, L, I'm sorry, L. E is equal to L. Okay, it is correct. And then L, remaining values of Li is going to be calculated with the formula minimum of Lj minus Dij. For last node, E is equal to L, that is right. And E is equal to L, remaining all values are going to be calculated by taking minimum. If you have one, Lj minus Dij formula. If you have more than one, then you have to consider minimum. So E is equal to L for last node. What is last node? Ninth node. That is E9 is equal to L9 is equal to 15. You see here, you observe here. E9 we got 15. Therefore, L9 we should consider 15. That is the first one. Now you have to coming back from ninth event to first event. That is, we have to consider next 8, E8. You see here the connection. How many connections are there starting from 8? That is, we are moving back 9 to 8. Any connections on how many connections are there? 8 to 9. That is, we have only one connection. 8 to 9. Therefore, it's simply subtraction. 15 minus 3. So it is nothing but 12. So I am using the formula. E8 is equal to L9 minus D8 9 is equivalent to B. L9 is 15. 15 minus D8 9 duration 3 is equal to 12. So the value is 12. E8 is equal to 12 here. Clear? And then coming to the 7, that is L7. Not is E8. L8. This is L8. I'm sorry. L8. Latest values we are finding latest values. Only the first one is E9 is equal to L9. The remaining values are L. That is L9. After that we have calculated L8. And then L7. L7 is going to be calculated. That is we have to calculate for this. How many connections are there? 7 to 8. From 8 to 7. From that is coming back to the 7, how many connectors are there? Only one. 8 to 7, that is 7 to 8. Therefore you have to subtract from L8 12 minus 4, it is 8. So therefore I'm using the formula L7 is equal to, it is connecting with 8, therefore L8 minus the D78 is equal to L8 is equal to 12 minus D78 is equal to 4. Hence it is 8. So therefore we have calculated L7 and then L6. So L6 is going to be calculated. You see here how many connectors for 6? 6 to 8. Therefore only one. Hence we can calculate directly. 12 minus, that is L8. 12 minus 1. It is 11. So therefore I'm using the formula now. L6 is equal to, it is connecting with 8. Therefore L8 minus D68 is equal to, L8 is 12 minus D68 is 1. It is 11. Okay. Next L5. L5. You see here L5. The L5 is also, we have only one connector. That is 5 to 9. This is what activity. Coming back to 9, we get 5. It is connected. So therefore 9 to 5. 15 minus 5. It is 10. So by using the formula, L5 is equal to, it is from 9th event. Therefore 5 9. That is L9 minus D59. So is equal to L9 is 15 minus D59 is 5. Hence it is 10. Right? And coming back, next L4. L4 is calculated. The L4 is calculated. Again we have only one connector. 4 to 5. From the diagram, 4 to 5. Hence it is 10 minus 3. Duration 3. Hence it is 7. 10 minus 3. It is 7. I am using the formula from 5th node. 4 to 5. Therefore it is L5 minus D45 is equal to, L5 is 10 minus D45 is duration is 3, hence it is 7. And then L3, coming back to the third one, we have, you see, observe here, third node, third event, it is connected from two other events, 3, 7, 3, 5. It is coming from 5 and 7. You have to consider minimum formula. I am writing the formula first. Because of the, you understand the formula from 5 and 7. So we are connecting with 5 and 7. Therefore, first of all from 5, L5 minus D35. And that is one formula, one value. And the second one, it is connected with 7. Then it is L7 minus D37. Okay, this is the formula. We have to consider minimum. So minimum of L5 is equal to, it is 10 minus D35, it is 8, and L7 it is 8 minus D37 it is 5. So minimum value 10 minus 8 2, 8 minus 5 3, so it is 2. 2 is the minimum value. So I am writing L3 is equal to 2. So I show from the figure. It is nothing but, you see, 8 minus 5. 8 minus 8, L7 minus 5. It is 3. And 10, L5, 10 minus 8. It is 2. Minimum is 2. That is what? 3. And the second node, we have only one again. Second node, that is L2. Directly we can calculate. It is getting from 6 to 6. So it is nothing, the formula L2 is equal to, it is from 6, therefore L6 minus D26. The formula L6 is equal to 11 minus D26. 26 is 4, hence it is 7. So therefore this activity is 7. This L2 is equal to 7. Clear? 11 minus 4 is equal to 7. Next from 1, that is 1. You have to consider it is connected from 3 nodes. 3 activities are there. 1 to 2, 1 to 3, 1 to 4. That is, we have to consider minimum. So I write the formula. You can easily understand now. L1 is equal to minimum of from second one, that is L2 minus D12. From third one, L3 minus D13. From fourth one, L4 minus D14. So this is what you have to consider minimum of L2. L2 is nothing but 7 minus 2. 7 minus 2. L3, 2 minus 2, D13 2. L4, it is 7. 7 minus 1. So this is 0. This is 5. This is 6. So minimum is 0. I'll show in the figure. This is L2. L2 7 minus D12. 2, 7 minus 2, 5. This is L3, 2, 2 minus 2, 0. And this is L4, 7, 7 minus duration 1. So it is 6. So minimum is 0. Clear? So finally, we got the values from L9 to L1. So this is what this is called backward pass calculation. From backward pass calculations, we have calculated L values, and for forward pass calculations, we have calculated E values. For which E is equal to L, you see the activities which are called critical activities. You see here E10, L10. Next, E3, E1, E2, L2 are not equal. E3, L3 are equal. Therefore, you connect this double line. It is called critical path. Okay, and then 2, 2. E4, L4 not equal. E5, L5 equal. E6, L6 not equal. They are not going to be considered. E7, L7 not equal. I'm sorry. E8, L8 not equal. You see here equal. E5, L5 equal 10 and 10. Therefore, E3, 3 to 5 is going to be connected. I am drawing double line. And then coming to that, E5, L5 and E9, L9 are equal. No other activities, for no other nodes, E and L are equal. Therefore, I am drawing double line here from E5 to, that is 5th node to 9th node. That is 5th event to 9th event. So that these are the 3 activities are connected. Therefore, the critical path, I write the answer for the second question. The critical path is 1 to 3, 3 to 5, 5 to 9. This is what critical path. What is the duration? The total duration, it is 15 days. It is 15 days. We can observe from the last node, last event, the value of E, either E or L. Because of we are calculating for forward pass calculations, I am considering E9. So therefore, the third question, answer of the third question is going to be considered. Third one is the minimum duration. The minimum project duration. Minimum duration to complete the project is 15 days. Minimum duration is 15 days. Clear? So this is what the forward pass and backward pass calculations and constructing the network diagram through the critical path method. In the critical path method, by using the critical path method, this is what the question you have to answer. In this way, you have to construct network diagram first, and then you have to calculate forward pass and backward pass calculations. Of course, we can calculate directly in the network diagram, and then the critical path is going to be considered, for which E is equal to L, and the minimum project duration is also going to be find out. Hope you understand. Thank you very much.